Hello everyone, welcome to Data Detectives, your go-to channel for unraveling intriguing insights hidden within data. Today we have an exciting project lined up for you where we will dive deep into the world of pizza sales using the power of advanced SQL and visualize our findings using Power BI. So let's put our detective heads and get ready to unveil some mouth-watering data. So the project name is Exploring Pizza Sales using SQL and Power BI. Before going towards the project outline, let's first of all see how our dashboard will look like and what will be the final product of this project. So here we can see that this is our final dashboard that has been created in Power BI. Here we can see that there are number of KPIs, that is total revenue, total orders, pizza sold, average total order value and average number of pizzas per order. So we will be generating these KPIs in SQL as well as Power BI. Then we will create some visualizations by category to understand what is the total revenue and also the total revenue by size. So we will be creating these charts. Also, we will be looking out which is the top revenue pizza for our pizza restaurant as well as which is the top order pizza in our restaurant. Okay. However, these visualizations will be dynamic by changing these parameters. Here we will use the parameter of Power BI to change different dynamic measures from total revenue to total orders to pizzas sold, and so on. Also, we will be creating some slicers to filter out and check dependencies of KPIs on different factors, that is start of the month. Here we will be giving the month wise bifurcation. Then we will see the week wise distribution. Also we will see the distribution of revenue and orders by the category. If we select the chicken, if we select supreme, classic, veggie, we will see all the different values for different categories. Okay, in the same dashboard we will be creating total revenue and orders on the basis of month bifurcation as well as the day wise distribution, as well as the hourly trend of orders in a particular day. Also, we will be comparing our monthly revenue, monthly orders, monthly sales, as well as the average order value in accordance with the previous month. So, we will be using KPI cards for the same. Also, in the dashboard we will be generating the product details. That is, if we want to drill through on a particular type of pizza, we can see the performance of that pizza on the basis of revenue and orders, and what is the distribution of different sizes that it served to the customers by using the drill through option in Power BI. You can see that the dashboard is completely dynamic, that is, it is changing on the basis of different parameters that are changed in the dashboard. So to make this final dashboard, what are the steps that are involved in this project? First of all, we will be importing our raw data in SQL and we will be pre-processing the data and perform some data analysis to generate some KPIs, and we will also see the distribution of revenues and orders in by category. Also, after that, once the data analysis is complete, once the data analysis is complete in MySQL, then we will be connecting our data into Power BI. We will be creating the data models so as to connect different tables in many to one relationships with each other. Also, we will be creating explicit measures using DEX so that we can generate KPIs perfectly. After calculating different measures like revenues, orders, and so on, we will visualize our data using different visualizations and charts in our dashboard. And after that, the conclusion will be drawing, and after that, the last step will be drawing conclusions from our visualization. So in the first part of this project, what we will do is we will perform data pre-processing and data analysis in MySQL on our data set. Okay, we will see the data set and its data description in MySQL, but before that, you can see that what are the KPIs we will be generating for our data. So First will be total revenue, that is what is the revenue of the complete so that is what is the revenue for the complete pizza restaurant. Then we will be generating average order value, what is the average order value. Then we will be see what is the total amount of pizza sold. Also we will calculate what are the distinct orders that we have made in our restaurant. Then we will see the average pizzas per single order. Okay, then we will move to sector wise analysis, that is we will see the sales performance analysis on different categories as well as on different sizes. That is we will be creating what is the revenue of the pizza across different categories and what is the revenue of the pizza across different sizes. So if you want to note down all the questions that we will be attempting in SQL for data analysis, you can pause the video and write these questions. Then we will move to After that, we will move to MySQL. Then we will do the seasonal analysis, that is which days of the week have the highest number of orders. Also, at what time do most orders occur, and also which month has the highest revenue. Okay. After that, we will be creating customer behavioral analysis, that is which pizza is the favorite of the customers, that is which is the most ordered pizza in this pizza restaurant. Also we will see what are the we will also see what are the top 5 pizzas by revenue. And third will be which pizzas have the most orders over the past year of the business at the pizza restaurant. Okay, in the fourth type of analysis we will be doing the pizza analysis, that is which pizza have the highest price, also which pizza have the least price. Second question will be what are the number of pizzas per category as well as what are the number of pizzas per size. And the fifth type of analysis is which ingredients does the restaurant need to make sure that they have on hand to make the ordered pizzas. So we have to analyze which ingredients are required so that we can make sure that we can prepare the pizza beforehand. Okay, so these are the questions that we will be attempting in our data analysis in SQL. If you want, you can write these questions. I will again show all the questions that we will be attempting in MySQL. You can pause the video. So first is KPI requirement, that is we will be generating 5 KPIs. Next will be sector wise analysis, that is we will be checking the revenue and calculating the revenue across different categories and sizes. Then we will be doing the seasonal analysis, that is we will be using the date time columns of the dataset to know the orders and revenue. Third will be the customer behavior analysis. So the analysis will be based on the customer's perspective, that is which is the favorite pizza of customers, what are the top 5 pizzas by revenue, as well as which pizzas have the most orders. Fourth will be pizza analysis, so which pizza have the least and the highest price, then which pizza what are the number of pizzas per category as well as per size. And the fifth part will be which ingredients does a restaurant need to make sure that the ingredients are available beforehand to make all the ordered pizzas. So first of all, what we will be doing is we will be first creating a database. So let's create a database with the name pizza underscore sales. So this will be our database. Okay, we have created our database. Then we will be using this database, that is pizza underscore sales. So the initial steps of this project is to first import the data and pre-process it. The same we are doing. So what we will be doing is, as you can see in the schemas, we have created a pizza underscore sales database. The tables or the data set for this project can be downloaded from the description in this video. On downloading the data sets or the tables, what you have to do is you have to store the tables in you have to store the tables in the C drive in the program data. And in the program data you will see the MySQL folder, and in the MySQL folder you will be seeing an upload folders. So in the upload folders you can store all your files. Okay, after storing all your files, when we will go on the table section and we will use the table data import wizard, we will select the files from that folder, that is the uploads folder of MySQL folder in the C drive. We will select our first table, that is pizza types. On clicking the next, you can see that the name of the file will be pizza types, and we will be dropping the table if it already exists. Next, we will be seeing that all the fields in all the columns are text type. So we will be selecting all the field types as text, and we will be clicking on next, and again clicking on next. We will be, so after clicking the next, you can see that the data has been imported successfully. There are 32 records that has been imported. Okay, when we click on the refresh, we can see that the pizza underscore types has been imported, and you can see that there are 4 columns, that is pizza underscore type underscore id, then you have name, then you have category, then you have ingredients. So the next table that we will be importing is, when we go on the browse, you can see that there will be one table, that is pizzas. On opening it, clicking on next, the name of the table will be pizzas. So you can see that there will be 4 columns. One is pizza id, that will be the text type. Then we have pizza type id, that will be also a text field type. Then we have the size, that will be also a field text type. And then we have the price, that will be of double type. Okay, so we will click on next, again next, and our data has been imported. We will click on next. You can see that there are 96 records that has been imported. Now we will see a different method to import the rest of the 2 files. What we will do is we will create table, that is orders, and in the orders table we will be giving the columns of the, if for the orders table, and it will consist of order id, which will be of int type and will be the primary key for this table. Next will be the date column, and that we will be first storing as a text data type. However, in the latest part, in the later stage of the project, we will be changing this date column to date data type. Okay, that we will include in data pre-processing part. And in the time column, we will be also selecting the text data type. After that, we will close our query and we will run this query. So we have created one table with the name orders. Okay, now we will be loading our data. So we will type load data in file, and here we will be copying the file path of the file. Okay, we will be copying the location of the file. Here you can see that my location is c slash program data slash mysql1 slash mysql server 8.0 slash uploads slash name of the file, that is orders.csv. Next we will be doing into table. So we will be importing our data into orders table, and we will be terminating our fields. Fields will be terminated by comma, and optionally it can be enclosed by double inverted commas. Okay, and lines in the csv file will be terminated by slash n, that is new line, and we will be ignoring the first row, that will be our column header. So on running this query, you can see that we have imported 21,350 rows in 1.390 seconds in our orders table. Okay, on refreshing our schema, you can see that we have imported our orders table. The same process we will be doing for our last table, that is order details. Okay, so let me do this. First it will be having order details, will be that will be int type, and it will be the primary key. Next it will be having the order id, which will be the int type. Then it will be having the pizza id, that will be a text data type. And then we have the quantity, that will be also int data type. Okay, so let's close this query and let's create one more table, that is order details. Now we will be using the same command. Let's copy and paste this, and we will change the file name that we have stored. It will be stored as order underscore details. Okay, and we will be importing our data in order underscore details table. Okay, and the field is enclosed by same comma and terminated by comma and closed by double inverted commas, and the line will be terminated by new line, and we will be ignoring first line as it will be a column header. Now on running this query, so we have imported 48,620 rows in our orders data order details table. Okay, now now let let us analyze our table. So first select star from orders table. So on running this query, you can see that we will be having order id, then we will be having the date of the order, then we will have the time. Next table will be order underscore details. So this also you can see that in the orders table the order id is unique, and the orders id also you can see that in the orders table the order id is unique for this table. So on running the second query, that is order details table, you can see that the order details is the primary key, but the order id in this table is having multiple rows for the same id. That is, you can see that for the order id number 2 there are multiple rows. Okay, then we have the pizza id, then we have the quantity. Okay, so you can see that here order id is a foreign key, however in the orders table it was the primary key. Next we will be seeing the pizzas table. So let's run this. So you can see that here pizza id is unique, however pizza type id is foreign key. Then we have the size, that will give us the size of the pizza, and then we have the unit price of each and every pizza. So you can see that the first pizza is bbq, that is short form of barbecue, underscore ckn, that is chicken, and the last alphabet is s, that will denote the size of the pizza. Next we will be seeing the pizza underscore types table. So on running the table you can see that we have the description, that is the name of every pizza, that is bbq chicken is the barbecue chicken pizza, and it will lie in the chicken category, and there are number of ingredients that is required to make pizza. Okay, so these are the columns for all the four tables. Okay, so here for data modeling in SQL, what we will do is we will combine these pizzas table as well as pizzas type table. Okay, so are uh, what what is our method is that we will consider our order underscore details table as a fact table. Okay, so if we run this table, you can see that we have the order details that is unique for this table. Then we have the order id, which is the foreign key, however it is the primary key for orders table, and it will be connecting this table, that is order details table, with the orders table. Also, the pizza id table, pizza id column will be connecting the table with our pizzas table. Okay, so instead of going for snowflake schema, that is pizzas order details will be connected to orders and pizzas, and then pizzas will be connected to pizza types. What we will do is we will connect the pizza types and pizza. So we will be following the star schema, that is pizzas and pizza type will be merged in one table, so it will create one pizza lookup table. Then orders table will be other orders lookup table, and the order underscore details will be our fact table. Okay, so what we will do is we will create a temporary table by using create view, and let's give this name pizza underscore details, and the columns that will be inside this table will be pizza id. Okay, other column will be pizza underscore type id. Okay, then it will be having the name that will be extracted from the pizza type table. Then it will be having category of the pizza. Then it will be having the size, and then it will be having the price, and then it will be having the ingredients. Okay, these will all these are the columns that will be present inside our pizza underscore details table. Okay, so we will be taking this data from our pizzas table, and we will give the name alias as p, and we will be joining this pizzas table with pizzas type pizza underscore types table. Let's give this name alias as pt, and we will be inner joining using pt dot pizza underscore type underscore id equals to p dot pizza underscore type underscore id. Okay, so this will create one view or virtual table. Okay, on refreshing our schema, you can see that we have created one view, that is pizza underscore details, and it will be having pizza id, pizza type id, name, category, size, price, and ingredients. Okay, so if you want to see the table, you can select, write a query pizza star from pizza details. You can write select star from pizza details. So here you can see that we have the pizza id, which is the unique id for this table. Then we will have pizza type id, that will be consisting of what is the type of this pizza. Then we will have the name, then we will have the category of the pizza, then we will be having the size of the pizza, price of the pizza, and the ingredients of the pizza. Okay, the next thing what we have to do is we have to change the data type of date column and the time column. Okay, so what we will do is we will write alter table orders, and we will modify date column to date data type. Okay, on running this query, we have successfully changed the data type. Also, for modification of data type of time column, we will write time. Okay, so on running this query, we have successfully changed the data type of both date column as well as time column. So this concludes the pre-processing of data. Here what we have done so far is that we have imported our raw data, then we have transformed our data, that is we have combined our data in pizzas table and pizzas type table into a one table, that is pizza underscores detail table. Then we have modified our data type of date column and time column for the orders table. Now also you can see that there are no duplicates as well as no null values. in this table, so we will not be doing any pre-processing related to the duplicate as well as the null values in the fields. Okay, so now let's start with the data analysis part. Okay, so the first question that we will be doing is we will be calculating the total revenue. So how we will calculate the total revenue is, what we will do is, so to calculate the total revenue, what we require is we have to multiply the quantity of every pizza with its unit price, and then we have to sum all the rows. Okay, so for that purpose what we will do is we will select and we will use the aggregate function, that is sum, and we will give here the od dot quantity and we will multiply it with p dot price, and we will give this name as total underscore revenue, and we will be extracting this data from order underscore details table, and we will give this name as od, and we will be joining this table with pizza underscore details table p on od dot pizza id equals to p dot pizza id. Okay, now let's run this query. So on running this query, you can see that the total revenue is 8.17 lakhs dollar. Okay, to be precise, it will be 817,860 dollars. So to limit the number of decimal, to limit the values after decimal, what we can do is we can round this value up to 2 decimal places. So the total revenue will be 817,860.05 dollars. Okay, and now we have calculated the total revenue. Now let's calculate to the total number of pizzas sold. So the total number of pizzas sold, how we can calculate? What we will do is we will sum all the quantities and we will name this field as pizzas pizzas sold from the table order underscore details, and let's name this as od. Okay, when we run this query, we can see that the total number of pizzas sold is 49,574. Okay, so the next API what we will be calculating is the total orders. So to calculate total orders, we have to calculate only the distinct orders. So what we will do is we will select and we will count. We will be using the count aggregation function, and we will be selecting only the distinct order ID from our order details table. Okay, so this will give us the total orders and we will be getting our total orders. Okay, so on running this query, you can see that the total number of orders are 21,350. Okay, now we have to calculate the average order value. So to calculate the average order value, what we have to do is we have to um, divide the total revenue by total number of distinct orders. Okay, so what we can do is either we can create a subquery or we can use simply select sum. So this is the same formula that we have used for calculating the total revenue, that is od dot quantity multiplied by p dot price, and we will be summing this. After that we will be dividing with the distinct orders. So this will be od dot order underscore id So this will give us the average order value. We can write average order value, and we will be copy pasting the same part, that is we will be selecting from order details table, we will be joining pizza details table on pizza id. So on running this query, you can see that the average order value is approximately $38. If you want to limit the values after decimal, you can use the round function also. Okay, so we have calculated the average order value. Now if we want to create if we want to calculate the average number of pizza per order, so what we have to do is we have to just divide the total number of pizzas by the total number of order. So for this purpose, what we will do is we will sum all the quantity of pizza and we will be dividing by total number of distinct orders. So we can use this. Okay, and we will be giving as alias name average number of pizza per order, and we will be using order details table. Okay, so on running this query, you can see that the average number of pizza per order is 3.2.32, but if we want to get in a complete integer, we can round and we can limit to single integer using the round function. So on running this query, you can see that the total number of average number of pizzas per order is 2 pizza. Okay, so we have generated all the KPIs required for our dashboard. Now we will be calculating the total revenue and number of orders per category. So here we have to, what we have to do is we have to just group the revenue and the orders by category. So what we will be doing is we will be using category, and rest will be more or less same. This will give us the total revenue, and this will give us the total number of distinct orders, total orders, and we will be using the same from order details OD, and we will be joining on pizza ID. This will be an adjoin, and the last step that we will add is we will group it by p dot category. Okay, so on running this query, you can see that we have calculated the total revenue as well as the total number of orders for each category. Okay, so if we want, now next question is we have to calculate the total revenue and number of orders per size. So we will be using the same query as used above, and instead of category we will be using size. So instead of category we will give size. Let's run this query, and this should give the bifurcation with the size. So you can see that the large pizza has maximum number of orders as well as the maximum number of highest number of revenue. If we want to see for the category, you can see that the classic category has the highest number of orders as well as the highest revenue. Okay, so this was the sector wise analysis. Now let's perform the hourly, daily and trend of monthly trend of orders in orders and revenue and revenue of pizza. So if we want to see the hourly trend in the orders, so what we will do is we will create the cases for the hourly trends. Okay, so what we will do is we will select and we will use the case statement, and when the hour in o dot time, so when in the time, if in the hour part of o dot time is between 9 and 12, that it means that from 9 a.m. to 12 p.m., then it will be late morning. Okay, however, if the hour is between 12 to 15, that is from 12 p.m. to 3 p.m., we will call it as lunch. If the time is between 3 p.m. to 6 p.m., we will call it as mid afternoon. If the time is between 6 p.m. to 9 p.m., it will be dinner. And if the time is more than 9 p.m., we will call it as late night. Okay, so we will be grouping our complete day in 5 sections, that is late morning, lunch, mid afternoon, dinner and late night. So for else we will give others. Okay, we will end this case statement and we will name it as meal time, and we will be counting the distinct orders using the same count distinct order id as total orders, and we will be taking this data from the orders underscore details table, that is OD, and we will be joining it with orders O. So we have to calculate the hourly trend and the daily trend, so we will be using the orders table that contains the order ID, date and the time of each and every order. So we will be joining it on O dot order ID equals to OD dot order ID. Okay, also we will be grouping it by meal underscore time. Okay, now let's run this query, and here we can see that the highest number of orders is in the mid afternoon, that is 6655. Then we have the lunch, which is 5395. If you want to group it, order it by in the descending order, we can use order by underscore total orders in the descending order. So on running this query again, you can see that the mid afternoon has highest number of orders, that is 6655. Then we have the lunch, then we have the dinner, then we have the late morning, then we have the late night. Okay, Now if we want to calculate the revenue, just we have to replace this count statement with the revenue statement that we have used earlier. Okay, so the same question is the assignment for you. You have to calculate the total revenue and bifurcate it on the basis of hours of each day. Okay, next we will do the daily trend or weekdays trend. Okay, so what we will do is we will select and we will use the function day name and give o dot date, and we will name it as day underscore name, and again we will be counting the orders, so we will use the same statement. Okay, we will be using the order details table OD, and we will be joining it with orders table with the alias name O on order ID. So O dot order ID equals to OD dot order ID, and we will group it by the day name, that is O dot date, and we will order it by the total orders in the descending order. So this will give us the week trend. Let's run this. So you can see that the Friday has the highest number of orders, that is 3538. Then we have Thursday, which is having 3239 orders, and so on. Okay, similarly if you want to see the month wise trend, what we have to do is we will copy the same query, and instead of day name we will use month name, and here also instead of day name we will use month name. So again running this query, you can see that the July has highest number of orders, which is 1935. Then we have May, January, and the least orders is in the October, that is 1646. Okay, now let's see the customer behavioral analysis, that is the most ordered pizza. Okay, so to calculate the most ordered pizza, what we will do is we will select, and now we have to use the name of the pizza, so we will give p dot name, and we will also see for which size the order is highest, and we will count od dot order underscore id as count pizzas, and we will be using order underscore details table, orders underscore details table od, and we will be joining it with pizza underscore details p on on od dot pizza id equals to p dot pizza id, and we will group it by p dot name and p dot size, p dot size, and let's order it by count pizzas in the descending order. So let's run this query, and we can see that the big meat pizza of small size has the highest number of pizza, that is 1811. Okay, then we have thai chicken, then we have 5 cheese, then we have 4 cheese pizza, then we have the classic deluxe pizza, then we have the spicy Italian pizza. Suppose if we want to remove the size, let's suppose if we want to see only the name, then if we run this query, so on running this query, you can see that the highest number of pizza irrespective of size is classic deluxe pizza. So we can give both the answers. If we want specific pizza, then it will be the big meat pizza by giving the size also, and if we want only the name of the pizza irrespective of the size, then the classic deluxe pizza has the highest number of count. Okay, so if we want to see only one row, we will use limit 1. So it will give the name of the pizza, that is the classic deluxe pizza is the most ordered pizza. Okay, now if you want to see the top 5 pizzas by revenue, so we have to uh, use the name of the pizza, then we will use the sum aggregation of OD quantity multiplied by P dot price to calculate the total revenue, and we will be doing the same thing, that is, let's copy this from orders detail, joining on the pizza ID and grouping it by p dot name. However, now we will order it by total revenue in the descending order, so it will give all the pizzas with their revenue in the descending order. Okay, so the highest is the Thai chicken pizza, then we have the barbecue chicken pizza, then we have the California chicken, classic deluxe, and spicy Italian. However, if we want to see only the 5 rows, we can use the limit option and it will give only the top 5 pizzas by revenue. Okay, so we have calculated the most ordered pizza as well as the top 5 pizzas by revenue. If we want to calculate the top pizzas by sale, so what we will do is, instead of total revenue, we will here give the sum quantity only. Okay, so this will calculate maximum pizzas sold, and we will be ordering it by pizzas underscore sold in the descending order. Let's run this query, and now you can see that the classic deluxe pizza has the highest number of pizza sold, that is 2453. Then we have the barbecue chicken pizza, then we have the Hawaiian pizza, then we have the pepperoni pizza, then we have the Thai chicken pizza. Okay, now we have done the customer behavior analysis. Next part is very much simple. We have to do the pizza analysis. So here we have to calculate the least price and the maximum price of the pizza. So what we will be doing is, we will be selecting name and the price column from the pizza underscore details table, and we will order it by the price. So on ordering it by the price, you can see that the least amount for a pizza is $9.75 for the pepperoni pizza. However, if you want to see the maximum price, we will use order by price in the descending order, and it will give the highest amounted pizza, that is the Greek pizza, which has the order unit price of $35.95. If you want to see only one row, you can use limit 1. Okay, so let's run this query, and you can see that there the Greek pizza has the maximum price. Now The last analysis that we have want to do is we have to see what are the most commonly used ingredients that we have to store beforehand for making our pizzas. So most top use ingredients. Okay, so there are two types of analysis that we can do. First of all, let's see the table. Select star from pizza underscore details. On running this query, you can see that the ingredients are separated by comma. Okay, so as the ingredients are separated by comma, what you can do is you can either, in the first simple version, you can either group it by the ingredients column. So it will group all the it will group the complete table on the basis of ingredients, but it will group all the it will group the complete table on the basis of ingredients, on the basis of distinct ingredients in these rows, and we will get the most used ingredient. Okay, however, if we want to calculate the most used ingredient for every single ingredient, that is what I want to say is, if we want to check how many times the barbecue chicken has been used, how many times red peppers is only used, how many times green peppers is only used, how many times tomatoes is used, how many times red onions is used. So this is the second type of analysis. Okay, so in this I will be giving you the code for the second version, that is the advanced version, where we are separating each and every row by the comma delimiter, and we will be creating separate columns for every distinct ingredient. Okay, but for the assignment, what you have to do is you have to calculate using the first version, that is grouping it by the ingredients only. So the code for the second version is, we will be creating first a temporary table, and we will be giving it a name numbers. So it will be, what is the use of this temporary table is, we have to check how many number of ingredients are present in one row, and for our purpose what I am doing is, I am selecting the highest number as 10. So I am assuming that there are at max 10 ingredients used in single pizza. They can be less also, however I am using at max 10. Okay, as we don't know how many ingredients are used, what is the maximum number of ingredients in the pizza. So what I'm doing is select 1 as n union all, then we will be doing select 2 union all, select 3 union all, select 4 union all, then copy it, paste it, copy it, paste it. Here I will replace it with 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Okay, let's close this query. Now what we will do is, we will select the ingredient from the subquery, and we will be counting the ingredient as ingredient underscore count, and now we will create a subquery that will be having the ingredient column. So we will use select, we will be using substring underscore index function to separate the ingredients by comma. Okay, so this ingredients column will be separated by comma for n ingredients minus 1, and this will be as ingredient that is used here. Okay, we will be taking this from order details table and we will be joining it with pizza details on pizza id. So we will give pizza details dot pizza underscore id equals to orders order underscore details dot order id, sorry, dot pizza id, and further we will be joining by the temporary table, and the name of the temporary table is numbers on char length of ingredients minus char underscore length ingredients and separated by comma. We have closed our complete query greater than equals to n minus 1. Okay, here I forgot to add replace, as it will be replacing the comma. Okay, it will be replacing the comma with single ingredient. Now let's close this subquery and let's give this name subquery, and now group our data by ingredient and order our table by ingredient count in the descending order. Okay, so let's first run this temporary table. We have created temporary table. Now let's run this query. So you can see that the garlic is the most commonly used ingredient in the making of pizza, with having the count equals to 27,422. Next, the most common use is tomatoes, which is have the ingredient count of 23,694. Then we have the red onions, then we have the red peppers, then we have the chicken, then we have mushrooms, then we have the cheese, pepperoni, and so on. And the least is, if we go on the table, you can see that the unique types of cheese like brie curry cheese, caramelized onions, pears, thymes, plum tomatoes are the least used ingredient. So to if we want to store the ingredients to make our ordered pizzas, we have to store at least these ingredients, that is garlic, tomatoes, red onions, red peppers, chickens, mushrooms, and so on. Okay, so this is the second version of calculating the ingredient. The first version is given as assignment because it is a simple one. What we have to do is we have to just group the ingredients by each column, each row. Okay, so with this we have completed our data analysis part in SQL. Now what we will do is we will be importing the data in Power BI. We will be data modeling we will be pre-processing our data, then we will create some measures, and after that we will create the visualizations and different charts for every KPI and every data analysis part. Okay, thank you.